All right. Good morning, everybody. Can you hear me? Can you see me? Can you see the screen? Anyone?
Can sir, sure.
All right. Let's take a minute to scan the attendance and then we'll begin with our class. Okay. Okay, it's 8:03. Let's begin our class. All right. Good day, everybody. How are you doing? I really hope that you guys are doing fine wherever you are at. As usual, if you're not doing fine, you're facing any problem, please feel free to voice it up to me. Please, my doors are always open, especially if it's related to the subject. If there's anything I can help, I'm ready to help. All right. So let's get back to where we left off. I understand that in the last quiz we had in the last class we had a quiz, right? And I think there's a little bit of problem with some of the question of the quiz. No worries on that. Like I think I inserted probably the wrong question into the quiz. My bad. So if there is a problem, I'll double check again if there is a problem in the answer in the question, and if there is a problem, then I will disregard that question. Okay. All right. That is in case you have a problem. Maybe some of you don't have a problem. Not everyone actually told me to have a problem. Okay, that's about the quiz, and let's go back to where we left off in from last class. Okay. Just a recap. The last class we covered something we call Boolean. Remember Boolean algebra. So we talk about some rules and some laws of Boolean algebra. So hope it's not too boring. I think it's not too bad because most of the laws they are actually common sense. So I really do hope that by this point you guys are kinda comfortable with the law that you don't really need to memorize because things have already start to make sense. Okay, so when things start to make sense, like these laws, you don't have to purposely memorize them, right? So we covered that in the last class. So I also put in some additional reference, like for example here in the footnote. So these additional reference are not needed, but it will significantly help you understand because I think like the author of this post here did a very great job at explaining. Okay, much better job than I can explain using my voice and in the class. Right. So this is a very good piece of article. So I highly encourage you guys to check this out. I've also posted this in our channel, so you just can just click in the link and it will bring you to this web page. Okay, that's something extra with that. So we went through a couple of laws, commutative law, distributive law, and then like some basic rules over here, right? And we also went through something called De Morgan's theorem. Okay, remember what De Morgan's theorem is about? It's all about breaking the bar. Okay, when you break the bar, you change the sign. So it works for this kind of case, and it also works for this kind of case. Okay, when you have a plus, you need to break your bar on top. Okay, right. So we went through a couple of example, I believe, on that. Okay, we apply it to this case where it's multiplication and then with the big bar on top. Like that, and also something like this with the addition and the multiplication, and we solve this in class as well as this one. Okay, so hopefully by now things are looking okay. Yeah. So I believe we solved this also in class. So today we are just going to continue on from where we left off in from the last class. So today we are going to talk still about Boolean algebra, and I think this class will be the last class we'll talk about Boolean algebra. So after this, from this point on, there will not be any more Boolean algebra. So don't worry, you don't have to do any more Boolean algebra simplification. I think it's kind of interesting because it's very satisfying to be able to simplify the Boolean algebra, right? So in today's class, we are going to finish off with Boolean algebra, and by the end of today's class, you should be very comfortable with Boolean algebra already. Right, so today we are going to talk about the expression of Boolean algebra. So it turns out that in Boolean algebra, you can express it in two forms. You can think about it like a format, okay? Just like number format, like you have base 2, base 3, base 1, so on. Okay, so Boolean algebra, you have two forms. One is called the non-canonical form, this the one in red, the non-canonical form. So this is the form that you're seeing so far. Okay, the form that you saw in your quiz, those are non-canonical form. And we also have the canonical form. So of course, I will show you what's the difference later. What's the difference between non-canonical and canonical, and how to spot them, and how to convert them. And canonical form is also known as standard form. So if you go to online references, some other books or some other maybe website, they will refer to canonical form as standard form. So don't get confused if you see this. If you come across this standard form in any other sources. Okay. So in my class, I will prefer to stick with this form, canonical versus non-canonical. Okay. So it's very simple. In canonical form, it basically means all variables are in each term. Okay, let me show an example. So suppose we have a circuit and we have three inputs, A, B, and C, right? So this function, so this here shows the non-canonical version. So the expression here would be, so we have F and then bracket ABC. It just means that this function has got three inputs, and this is the expression. So this is the non-canonical form. So why do I say it's non-canonical form? Because each term do not have all variables. So how many terms do we have here? This is one term. This is another term. Okay, so in this term, we only have A. We don't have B. We don't have C. In this term, we have B. We have C. We don't have A, anything related to A in this term. Okay, so that's why this is known as the non-canonical form. Okay, but there is a canonical form expression also. So these are the same function, exactly the same, but you see over here that in each term, you have all the variables. Okay, so this term you have ABC, every term is the same. All right, and these two terms, they are same. So what do I mean by that? So if you take this equation, the second equation, and you simplify it, using laws or Boolean algebra laws or rules, okay, you would get this one. Okay, so from a complicated canonical form, you simplify it, you will get this non-canonical form. Okay, so this the simplified version of an expression is usually the non-canonical form. Okay, so get it what it means. So you have non-canonical and you have canonical form, right? And they are both different format of writing an expression. So at the end of the day, the value, the truth table of these two equations, they are supposed to be the same. Okay, so just bear that in mind. Non-canonical and canonical. So from non-canonical, okay, let me erase this. From from canonical to non-canonical, you can simplify using. So if you simplify it using Boolean algebra rules and Boolean algebra laws and De Morgan's theorem, whatever, you get the non-canonical form. Okay, but what if you want to go from this form into this form? How do you get that? So this is what we are going to cover in today's lecture. So suppose you have an expression that is non-canonical, then you want to make it canonical. So let's take a look how we do that. Canonical form. Let me take a sip. Yeah, canonical form. So this is something new that I want to introduce to you guys also today. And there are two methods to write the canonical form as well. Okay, so the first one is known as sum of products. Sum of products, so the blue one, or in short, we'll call it SOP. And product of sum is the red one, is called POS in short. Okay, so what if you have a circuit with 3 input variables, and let me show you an example of what a SOP form would look like. It looks like this. Okay, so basically what it means is a sum of products, okay, which is the sum of products. Products are the smaller one, the inside one, products. Okay, sum of products. So what if you have the same expression, but you put it into another format? So that format will be the POS format. Okay. So what if you have the POS format? So if you have a POS format, then your equation would look something like this. Okay, so this is product of sums. Okay, so we see here there's product between the brackets, there's product, and inside the bracket you would have sum. Okay, so again, SOP, POS, are they the same expression at the end of the day? Yes, they are the same expression. The truth table must be the same, even though you use SOP or a POS form. Okay, it's just two different sides of the same coin. You can think about it that way. So it's a two different ways of writing expression. Okay, so now you have some. Now let me make the picture clearer. So in Boolean expression, we have non-canonical and we have canonical. Okay, and inside of a canonical, inside of both of this actually, we have two formats: sum of product. Okay, so hopefully that makes sense right now. So how do you identify SOP form? It looks something like this. You have a product, and then inside the product you have the multiplication. How does product of some expression looks like? It looks like something like this. Okay, maybe this second one you're not very familiar with, because so far we've only dealt with the first one. Okay, but you take it. If you take note, you would find expressions that are like this as well. Okay, so these are okay. So this is an example of canonical. Why is it canonical? Because each term has got all variables. Canonical SOP. Okay. Now over here we have a canonical POS. Okay. Why do I say it's canonical? Because every term over here has got all the variables. And why do I say it's post POS? Because it's a product of sum form. Okay. And over here is a sum of product form. Right? So hopefully that makes sense right now. So this one I think is an important diagram. Maybe I'll include this in my slide. from this point on. All right. All right. So the other thing that I'd like to introduce to you guys is the name of the term. Okay. So in a canonical SOP form, each term over here, they are called a special name, and that special name is min term. Okay. It's MINTERM, min term. Okay. Same thing in a canonical POS or canonical POS, each term over here, they are also known as max term. Okay, so if I talk about min term, then you automatically know that, okay, this has got to be canonical SOP. And if I talk about max term, you know that it's got to be canonical POS. Okay, that is the introduction of the terms. So let's talk about in a little bit more in detail about what those are. Okay, those are the terms. Okay, so suppose we have a digital circuit with 3 inputs, and so if you construct a truth table, you would get something like this, right? The input is starting from 0, 0, 0, and it will end at 1, 1, 1 because it's just a 3 input. And how would the output look like? So the output, of course, the output will depend on the circuit. So you would have like a output, and you would start to fill the output, right? So the output, the first row, the output depends on the type of, on the expression of the circuit, and so on. Okay, so let's say you don't have the expression of the circuit yet, so the output will look like this. Okay, this is how we write the output. Like, we don't write it in terms of value 0 or 1, but we write it in terms of the input variable. Okay, so we can write it in terms of min term. Okay, so take a look at how it's written. Okay, so the output here we see, sorry, this is not the output. This is the min term. The output is something else. Okay, this is the min term, how we write the min term. So the min term is written as A, B, and C. So all the min terms have A, B, and C. And you have 0, 0, 0 over here, and the min term has bar on all the 3 terms. Okay, it's A bar, B bar, and C bar because you have bar, it represents 0. Okay, same thing over here. We have A 0, 0, 1, then you have A bar, B bar, and C. Now C is without a bar because it's a 1 over here. This is okay to represent the input. So O10, same thing. So the thing to remember over here is for min term, you have a bar on 0. Okay, for min term, you have bar on 0. Whenever you have a 0, you have a bar. Right. So the other thing that I'll need you to know is also that there is a number associated with the min terms. Okay, so this is also called min term 0, min term 1, min term 2, and so on until the last min term number 7. Okay, so now if I say, okay, give me the min term number 7, you automatically know that min term number 7 means the input value of 1, 1, 1. Okay, because I know that min term 7 corresponds to this line. Okay, so now say min term, give me min term 6. What's min term 6? Min term 6 is 1, 1, 0. Okay, the input value of 1, 1, 0. So that is how we address the min term and its value. So key point over here, min term bar on 0. Okay, so these are some examples. So based on the truth table, write the canonical form expression as a sum of its min term. Okay, in other words, it's SOP form. So what we want is a canonical SOP. Canonical SOP. So this is the truth table. Now, so how do we write this entire truth table using just the min term? Okay, firstly we write So previously in the in a Boolean expression, so we have this x, and then you get the equals to, and then you have the Boolean algebra, right? In terms of a, b, c, and so on. Okay, but the other way to write it is in terms of minterm. So how do we write this in output in terms of minterm? Is that we look at this truth table, and we look at the value that has 1, right? And we look at this, and we write down, okay, what minterm this is. This is minterm 0. This is minterm 2. This is minterm 3. This is minterm 5. Okay, how do I know it's minterm 0? Because it's 000. Okay, minterm 2 is 010. Same thing over here. Same thing over here. So how do I write this output in terms of its minterm? So the output is written as M0 plus M2 plus M3 plus M. That is how we write the output in terms of the minterm. Okay, so if you were to take this one step further, you can turn this minterm into canonical form. So minterm 0. What is minterm 0 in if you were write it in ABC? Okay, in terms of the input variable, you would get A, B, C with the bar on top. Okay, what is minterm 2? Minterm 2 would be here. Okay, I'm just taking this value here because 2 is 010. Okay, and then we have minterm 3, which is A bar, B, C. And then finally we have minterm 5. We have 101. Okay, so 1. This is 1. This is O. This is 1. Okay, so minterm 5 over here, 101. So the bar is on the second term, B. All right. So this is our canonical SOP form. Okay. So we have a truth table. Once you have a truth table, then you have this one value inside there, and then you can get the minterm number, and then you can write the minterm numbers like this, and then that's how you get the canonical SOP form. Okay. So let's say now I said that I want you to simplify. Okay, this equation over here, it looks complicated and it has a lot of gates. Now, as a manufacturer, you want to make this circuit as simple as possible, and you can simplify it using Boolean algebra laws, okay, or rules. And you have a simplified SOP. Okay, simplified sum of product. This is canonical sum of product. Okay, so that is what I want to illustrate in this example. Any questions so far for this one? Okay, right? Okay, so in this example over here, there is also a more compact way of writing everything. And take a look at this last equation over here. So this is the more compact way of writing everything. So you have a f in function of a, b, c. So a, b, c is the input, and this is equals to what we have on top here actually. Okay, so I'm taking this one and I'm rewriting it like this. So in a sum, this is sum of m stands for the minterm, and then the bracket inside there tells you the minterm number. Okay, so it's minterm 0, 2, 3, and 5. Okay, so this is like a very compact form, especially if you have a lot of minterm. Okay, you have 32 minterms. Okay, so maybe this is a preferred way of writing instead of writing one by one over here. Minterm 0 plus 2 plus 3 plus 5 and so on and so forth. Okay, so now from if I give you this form, you can change it into this form above, and you can also change it into the canonical SOP form. So these are all different ways of writing the same thing. Okay, so hopefully that makes sense. That's all about minterm. Now, let's talk about max term. So suppose we have the same circuit. Okay, so still the same 3 inputs. This table input will be like that. So now we want to see how does the max term look like. So the max term looks like this. Okay, so the max term looks like this, and the way we write the max term is a capital M. Just now was a small letter or lowercase m. This one is a uppercase M. So that's the difference between a min term and max term, how we write that. Okay, so take a look at what is the difference over here between min term and max term. So firstly, the difference over here is that this max term is always in terms of POS. In terms of POS, if you take a look at every row over here, it is always product of some form. Okay, so there's always so A and then plus B plus C. So as opposed to this. Okay, A multiply with B multiply with C. That's the difference. Okay, and that's so the second difference that you see over here is that the bar. So previously we have the bar whenever we have 0, right? Remember? So if this were to be in min term, it would be written as A, B, C, and then there's a bar, bar, and bar over here. Okay, but for max term, it's the other way around. So for max term, the bar is on 1. That's what I want you to notice over here. For example, we have 001 over here. If you were to write it in min term, it looks like this. This is min term, 0, 0, and 1. But if you were to write it in max term, it would look like this: A plus B plus C bar. Why is there a bar at C? Because over here the C is a 1. Okay, so hopefully you notice that as well. So let's take a look at the last one. And min term 7 is 111, so they are all bars on top. Okay, so that's the concept over there. Hopefully I made it clear. So what's the difference between min term and max term in terms of the how we write it? So in terms of how we write it in M, one is a small letter m or lowercase m, the other one is a uppercase M. So the other difference would be the bar. For min term, the bar is on 0. For max term, the bar is on 1. All right, so let's take a look at an example. So based on the truth table like this, same truth table, now we want to write the canonical form expression as a max term, as a product of sum in its max term form. Okay, so in other words, we want the canonical post form. Same thing, what we are going to do is we are going to identify, previously we identified the ones, right? Remember, we identify which one's the 1, 1, 1, and we mark them as the min term. Okay, but for the max term, we don't identify the ones, we identify the other one, which is the 0. Okay, we identify the zeros over here. Okay, so we identify 0. So this 0 is max term number what? Number 1. This is max term number 2. So why is it number 2? Because this is 0, 1, this is 2, 3, 4, 5, 6, 7, right? So this is max term number 6, and this is max term number 7. So how do we write it? So once we identify the zeros, so the way we write it is like so. So previously we write it in the form of summation, right? Summation of all the min term. But for the max term, it is a multiplication. So it is the output x is a multiplication of all the max term. Max term 1, max number 2, 6, and 7. Okay, so again, if you were to take this and expand this and write it fully, you would get what is M1. So M1 you would get over here A plus B plus C bar. So why is there a bar? Again, for max term, the bar is on the 1 because I have this one, 1. Okay, and what is M2? So M2 would be A, what's 2? Okay, A plus B bar plus C, because you have a 1 over here. Okay, so same thing. What's M6? M6 is 110, right? So we have A bar plus B bar plus C. That's M6. And M7 would be A bar plus B bar plus C bar. Okay, that is how we write this. Okay, so what about the compact form? Yes, this is the last one that we saw just now. This is the compact form if you have too many max term to write. Let's say you have 32 max term to write. So it'll be a lot to write if you want to write it in terms of the expression over here, ABC, and in terms of this one. So a more compact form to write the max term is like this. So this symbol over here is a symbol of multiplication. Okay, so summation symbol is like this, and this time it's not summation, this is multiplication, and M stands for the max term, capital M. Okay, capital M, uppercase M, and then in the bracket it shows all the max term number. Okay, this is another way of writing it. So if you have this form, you can change it into this form, you can change it into this form, you can even get the truth table out. So I hope you're seeing how is it all related now. So from truth table, you can get the max term, you can get the min term, you can get canonical, you can get the simplified, you can also get this compact form. Okay, so that's about min term and max term. So after this, we're going to do some examples, and then we can end our class today. Any questions so far? Is it clear?
No question, sir.
Okay. Let me take a drink. Okay. Right. So now we are going to see if we have one canonical form, can we convert them to another canonical form? The answer is yes, we can. And the good news is it's not very hard to do at all. It's like so easy to do. So let's say if I have a canonical form, okay, let's take a look at, let's focus it over here. So let's say I have a min term number. Let's say I have an expression and I know the expression has this min term. So how do I get the max term number? So this simple. So the min term is 1, 3, 5, 7. So we know from the last example that this is the max term, this is the max term, this is the max term, this is the max term. Whatever that's left is the min term. Okay, so same thing over here. So we have the min term over here, 1, 3, 5, and 7. So whatever that's left is the max term. So this is how you get the max term. The max term. So whatever that's missing from this top part over here is 2, 4, and 6. So that is how we get the max term. Okay, again, once you get this compact form over here, you can always change the compact form into the expression. Okay, so hopefully that helps you understand what is the difference between the min term and max term. It's telling at the end of the day, the min term and max term, they describe the same truth table. Okay, they describe the same truth table. The values they describe, they're the same. Min term will take the ones out, max term will take the zeros out. Okay, and they write it a little bit differently. The circuit is also different, but then at the end of the day, do they produce the same output? Yes, they still produce the same truth table. Okay. Okay, let's take a look at an example over here. Okay, so this is an example. This is what you can expect in your quiz or in anything in your assessment. Okay, right. So suppose you have an expression over here, A, B, C, D, and you have this given, and you're told that you express this in the canonical SOP and POS form. All right. So at this point, I highly encourage you guys, as usual, when you're doing example, the best way for you to learn is to do it together with me. So if you have a pen and paper, I encourage you guys to work it out together with me. All right. So let's take a look at how we turn a simple like this expression over here This is a simple expression, maybe, okay, and into a canonical SOP and POS form. All right, first thing first, we take note at what are the variables that we are seeing in here. So we know that this expression has got A, B, C, and D. All these are 4 variables. So we see that, okay, the first expression, the first term over here has A and B. Okay, it's missing C and D. The second term over here has got A, C, and D. It is missing the B inside there. So what we want to do is to put in the missing terms into here. Okay, so we have A bar, B. So we want to put C into here, we want to put D into here, and we want to put in B into here. Okay, but now if I put C into here and I put D into here, am I changing my equations actually? If I'm changing my equation, well, I cannot change the equation. If I change the equation, then the truth table will change, right? So, but there is a trick we can do to put in the terms like C and D, but we don't change the equation. So what is it? All right, again, go back to this Boolean algebra laws. Okay, so we are going to use these 2 things. A plus A bar is 1, A multiply A bar equals to 0. Okay, so how we do this is, let me write this down. Okay, I'm going to omit this A, B, C, D. So we write here A bar, B, C, D, like that. Okay, so let's work this one out first. The one with missing B. So we can do this. Multiply by 1. Can I do this multiply by 1? Yeah, I'm not changing the equation, right? A, C, and D multiply by 1. I still get A, C, and D. Okay, let me write this nicer. Multiply by 1. No problem, right? But, okay, take a look at this property over here. A, so how do you get a 1 inside here? You can write A or A bar. So I can write over here inside this bracket B plus B bar like this. Okay, because we know that this thing is just 1. Okay, so that's how we know that, okay, I'm not changing the equation actually. The value of the equation will still stay the same because this is just a 1. Okay, so if I multiply this out, I would get like this: A bar B plus, and I will get A. I do the multiplication, B C D, and a plus A B bar C D. Okay, look at that. Is that magic? Now I have, originally I have this A, C, and D. Now I have just make this A, C, and D into 2 separate terms, which is this 2 over here, and now they both contain all the variables. Okay, that is how we make it into a canonical form. Okay, now I'm going to go ahead and do the same thing for this one. So we see that it's missing A bar. It's missing over here. It's missing the variable C and variable D. So I'm going to go ahead and add that in. So we are going to do this: A bar B, and we're going to add in this. Okay, C plus C bar. So because this is just 1, I'm not changing anything, and the rest of the equation, I'm just going to write it as it is. Okay, so then I do the multiplication, then A, B, C plus A bar B, C bar. B bar, C, and D. Okay, so now I see that, okay, it's now got A, B, and C. It is missing one more term, that is D. So I'm going to go ahead and add into here and into here, D. Do that. So you have A, B, C, and I'm going to multiply with D plus 4, that, and I'm going to go here A, B, bar, and over here we have d bar, like so. Okay, the rest of the equation would stay the same. Okay, let me double check my work. Okay, this one becomes this. Okay, ABC. Okay, bar on both end. Okay, I put in that ABCD. Okay, okay. So now the final thing to do is just to expand all this. A bar, B, C, D, and then you have A bar, B, C. This time is D bar, and then finally we have A bar, B, C bar, D, plus A bar, B, C bar, D bar, plus A, B, C, D, plus A, B bar, C, D. Okay, so this is your canonical SOP form. Is there any question for this one? Okay, because at the end of the day, we see, okay, we have all the terms over here contains all the variables. Okay, so can I write this in a more compact form? Yes, we can write this in a more compact form. Let's try that. So over here we have, so remember this is SOP form, canonical SOP form. So the bar is on top of 0. Okay, so hopefully there's no careless mistakes here. Let me just double check again. ABC, okay. D and D bar. Okay, so let's try to figure out what minterm is this. Okay, so this one is, okay, let me change my pen color so that it's easier to see now. Red color. Okay, so right now we have over here A bar is 0, 1, 1, 1, right? B is 1, C is 1, D is 1. So this is minterm number what? 0, 1, 1, 1 is M7. Cool, M7, right? So, okay, so now we have, next we have O, 1, 1, O. So this is M what? M, minterm number 6. O, 1, 1, O is 6. Okay, same thing over here. We have O, 1, O, 1. Okay, O1, O1 is minterm, minterm 5. Okay, 101, 110. Okay, and next what we have? We have O1, O, O. So O1, O, O is minterm 4, right? Yeah, minterm 4. Right, and next one we have 1, 1, 1, 1, which is the last minterm. This is minterm 15. Okay, and what about this one? Oh, sorry, this is 1, 0, 1, 1. Okay, so 1, 0, 1, 1 is minterm, so 1, 0, 1, 0 is 10, 1, 0, 1, 1 is minterm 11. Okay, so once we get this minterm number, now we can write it in the compact form, just now remember. So we have this F, and we have A, B, C, D. So we can write it as a summation of minterm number 7, 6, 5, 4, 7, 6, 5, 4, we have 15 and 11. Okay. So this is the minterm list. Okay, minterm list for this expression. Okay, cool. I think it's any problem so far? How I get this one up here? Is anyone can anyone get the same answer, or do you spot any error? Sometimes I do make some silly mistakes here and there.
Same answer, sir.
Okay, thank you for the verification over there. Okay, now we are done with the SOP form. Now, how are we going to change this into a POS form? Okay, there's a few ways to do it. But the easiest way is to get this, and then you get the POS form from the max term, right? So what you can do to get the max term. So let me change my ink color into orange. So we want to write this max term form now. A, B, C, D. Okay, the max term form, this is how it's written, and it is capital M this time. Okay, let me write this better. Okay, so the max term will be all the missing terms inside of the min term. So that will be 0, 1, there's 2, 3, okay, 4 is here, 5 is here, 6 is here, 7 is here, 8, you have 9, you have 10, then you have 11 is here, you have 12, 13, 14. Okay, so 1, 2, 3, 4, 5, 6. You have 6 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's about right. 16 altogether. Okay, so once you get this max term list like this, now what you can do is to expand this into the canonical post form. Okay, so how do I get the canonical post form? Okay, I can get this. 0 becomes the max term. It's written as A plus B plus C plus D. Okay, you can write this as F. And what about 1? 1 is A plus B plus C plus D. And remember, for post POS, the bar is on the 1. Okay, that is this one. Okay, what about number 2? Okay, I can write this here over here. A plus B plus C plus D. So 2 is 1, 0, right? Okay, so the bar should be here. Okay, and you can do that for every single term over here, and this will result in a giant equation at the end of the day. Okay, that is how we get the canonical POS from canonical SOP. So hopefully that is clear. Okay, all good. All right, so the slide over here has this final answer, but it does not contain my scribbling over here. So if you want to watch this, what I scribble, so this in the recorded video. All right, that is one example. Okay, so let's take a look at another example. So now I have another equation. This time is a little bit different. So we have over here, this is like a POS form, okay? Turn it into canonical product of sum and canonical, okay, basically we want a canonical post and canonical, so we want this too at the end of the day. All right, so how do we do this? Just now, we relied on this tip, remember? And we use this multiply, okay? We use this, we use either this one or this one, but bear in mind we cannot change the equation. Okay, so just now we multiply the terms by 1. So in effect, we are not changing any equation. Okay, let's try to see if we can do the same over here. So what I'm going to do is, okay, so let's take a look at what missing term this has. So A, B, and C. This one is missing D, and then over here this is missing B, and over here is missing A. Okay, A, C, A, B, C, D, A, B, C, D. Okay, so that's about right. So in the first term, I need to insert D into the first term. Okay, let's try to do that. So we have A bar plus B bar plus C, right? So just now, what we did was we multiplied it by 1, right? So, but that works for SOP only. So for POS, what we need to do is we need to add a 0 inside. So what we're trying to do over here is that we want to add 0 over here. Okay, so 0 is, you can use this as 0 as well. So it's A dot A bar. So I can write over here D bar like that. Am I changing the equation? No, I'm not changing any of the equation, right? Because I'm just adding 0. So you add 0 means you don't add anything. You still get the same truth table. So, but in effect, you are already adding the B, okay, the D, the variable D into this first equation. Okay, so I'm going to do the same for this one. A plus B bar here plus C bar plus A. And get B, so A bar plus B plus C plus D bar, like that. Okay, still the same equation because I'm just adding 0. Okay, so now, how do we expand this? How do we make this like into the canonical form, right? So let's take a look at, let me bring you back to one of the laws because it might not be very obvious over here. Okay, so take a look at this law, this law over here, the last one. So it says that something A plus BC, so you can change it into A plus B and A plus C. Okay, you can write it in other letters. Okay, so you can write X plus Y Z. You can also write X. This is also equals to X plus Y, X plus Z. This is the same. Okay, A plus BC is A plus B, A plus C. Okay, so is this the same over here? It's the same, right? X plus Y, Z. So I'm just using a different letter because I don't want to confuse you with the example that we are working on. The example we are working on uses ABC as well. So, and in this law, I'm also using ABC. So I'm changing the letter so that it's not as confusing. But I'm making sure right now it's still the same thing. X plus Y is Z. So we have X plus Y, X plus Z. Let's go back to our example. Our example over here. Okay, this is our example, right? Yeah. Let me rewrite that. X plus Y Z is equals to X plus Y. It's like my Y. X plus Y. X plus Z. Okay. So take a look over here. Do you see something very similar here? Okay. So, okay, let me change my highlight color so that it's easier to see. So the point is we have X over here and we have X over here and we have X over here. They're all in green. Okay, now let me change my highlighted color, pen color to yellow. Okay. And you have Y over here and you have Y over here. Okay, Then you also have, see, purple. Okay, you have Z over here, and then you have Z over here. So based on the color, you know where each variable goes, right? Now let's take a look at what we have over here. Okay, so we have X over here. We have X over here. This is the X over here, okay, which is the same in green. The Y over here is the yellow one, okay, which is this one, and the Z is the purple one, in color and purple. This is Z. Okay, now hopefully that is much clearer right now. So based on this, so we can rewrite the entire thing over here. Okay, let's work on this first term, just the first term. That is not as messy. Yeah, go back to blue. Okay, so I can rewrite this entire term like this, right? A bar plus B bar plus C plus D, and A bar plus B bar plus C plus D bar. Take a moment and digest. Is this the same thing? Is this the same as what we are seeing on top? Okay. So we have this one, green, and then we have the yellow. Okay, we have the yellow over here, and we have the purple one. Purple one over here. Okay, so that is how I arrive from this first term over here, and it breaks down into the second term using this Boolean algebra law. Okay, right. So can I do the same for the second and third? Yes, I can do the same. Let's do the same for the second and third one. Wait, so far, is everyone following up to this point? I remember people got confused at this point last semester, so that's why I'm spending a little bit more time here. So what's so good? Okay, so then I'll continue. So you have A plus B plus C bar plus D, like that. And you have A plus B bar this time, plus C bar plus D. And then the final one would be A plus B plus C plus D bar. And you have A bar plus B plus C plus D. Okay. Okay, so A, so over here is B, and then the other bar is there, and then the rest are the same. C bar, D, C bar, and D. Okay, A over here, A bar is there. So B, C, and D bar, B, C, and D bar. Okay, looks about right. So this is our canonical post form. Canonical post form. Okay, so can I write this down into a more compact form? Yes, let's try that. So let's try to change this ink color into something else. So we have this max term. This time is max term, right? So max term. So this is bar is at 1, right? This is 1 1 0 0. This is 1 1 0 1. This is 0 0 1 0. This is 0 1 1 0. This is 1 1 1 0. This is 1 0 0 1. Okay, did I have any mistakes there? Okay, double check. Double check might work. Okay, yeah, I do have a mistake over here. Bar is at 1, right? It's 1, this O, O, O. 1, 1. Okay, any more mistakes? Bar is at 1, bar is at 1. bars at 1, bars at 1, bars at 1, bars at 1. Okay, so 1100. So which max term is this? Anyone can remember? 1010 is 10, 1011 is 11, 1100. Okay, let me just go back to this table. You would see that, oh, it's not even here. So let me go. Okay, it's okay. So 1100, what is 1100? I got 1100, that would be 12. That would be max term number 12. So 1101, okay, 1101 would be max term number, the next one, 13. This one would be the max term number. This is 2, so 0010 is 2, right? Okay, max term number 6, and this one is max term number 0001. So max term number 1, and 1001 is max term number 9. 12, 13, 12, 13, 2, okay, 6, and 1, and 9. Okay, looks right to me. Okay, and we can write this in terms of this max term, 12, 13, 2, 6, 1, and 9. That is the canonical, that's the max term form. Okay, what about the min term form? So the min term form is just the inverse of that. So we are going to change this. So the min term form would be a summation of min term. And then you have 0, 1 is here, 2 is here, 3, and then 4, 5, 6 is here. You have 7, 8, 9 is on top. You have 10, 11, 12, 13 is above, 14, and 15. Okay, and from here, what you can do is you can write this in the proper min term form in A, B, C, D. So this one would be A, B, C, D, and this would be all bars. Remember, the bar is at different point. So we do the same for all this, and that's how we get the canonical SOP form. Okay, so above we have the canonical POS, and below we have the canonical SOP form. So guys, that is how we change from one form to the other form, and without changing the equation at all. And at the end of the day, they are all equivalent form. Okay, so it's slightly different depending on what you get, what you have over here in the beginning. So if the beginning you have this POS form equation, post form, you want to use this one, this law over here. But like the previous example, in the beginning you have some SOP form, then you want to do this one over here. Okay, so that is how we solve a question. So I have one more example to go through, and then we will end our class today. So this is an interesting example. So let's say you have this function x, y, z, and then this one is, this is in post form, right? This is in post. Sorry, it's not post. This is in slope form. Is it canonical? No, it's not canonical. Okay, but it is in the SOP form. Okay, and we want to change it into the POS form. Okay, but you want to change from SOP to POS. Remember, we need to go through make it canonical, and then like after that write the giant super duper long equation and everything, solve it like through that, and you hope that you won't make any mistakes in between. But there is another method that you can use to change this SOP form into the POS form. Okay, bear in mind, this is not canonical. Okay, your answer will not be canonical form. It's just changing SOP to POS form. Okay. Right. So what you can do is to do double negation, and then we'll run De Morgan's theorem. So how does that work? Okay. So remember that one of the laws says like this. Okay. If you have a double negation like this, it actually cancels one another out. So I'm not changing anything with the equation. Okay. So I want to do the same thing over here. So I can put a like double bar on top here, and I'm not actually changing anything. So let's try that. So we have f, and we have y bar plus x bar, and we have like a double negation like this. Okay, so this one goes here. Like, you can write this here like that, f double bar on top. So what we like to do right now is to break this bar down into using De Morgan's theorem. Okay, so what we want to do, okay, let me just take away one bar, and then we do one bar at a time. Okay, so we do f bar first, and then we do f double bar after this, so that is less confusing. So I have over here y bar, and then I have a bar, and with multiplication x c bar like that. Okay, breaking the bar, and I'm changing the sign. Breaking the bar, and I'm changing the sign. So I have here y dot, and then I'm breaking this bar again, x plus z. Okay, so multiplication, change in addition, x. Okay, so that we are done with the first bar. Now let's try with this double bar. X double bar now is y dot x bar plus z, like that. Okay. Okay, so if it is equals to, I'm just gonna break this down again. Y y bar like that, and then you have plus, and then you have x bar plus c, and you have that. Okay, y. Okay, then you have that. If x multiply with wait, this does not make sense. Sorry, give me one moment. I think I messed up somewhere. Double bar. Dot.
So,
Yeah, can anyone see?
should I the third step, you change it into x bar y plus yz.
X bar, the third step, 1, 2, 3. So x, x bar.
X bar y.
Yes. Okay. That is the mistake over here. That's why it's not making sense. Okay, let me just take away all this mistake. Yeah, thank you for catching that. This is why I need you guys to work it out together with me. Okay, so this this one, yeah, this one. This is what you're talking about, right? Yeah. So then, if we do this 1 plus y, say, x bar y plus, okay, so this is f bar. Is this what you're referring to? I didn't get your name. Oh.
Yes, sir.
Okay. So this is the first bar. Okay, now let's work on the second bar here. F double bar is let's take that x bar y plus y z bar. Okay, now we're working on the second bar. Then okay, so that's why it's important to put in the bracket, right, so that you are not confused with that. Okay, so let's try this one, x bar y, breaking this bar over here. We put a bracket like that. Bracket over here also y z. Okay, yeah. So then let me just break this down again. X double bar cancels out, plus y bar, and this bracket again, y bar plus z bar. Okay, this is f double bar. Okay, so when you are done with the double bar, you would arrive at a post form. This is a post form. Okay, is it a canonical post? No, it's not canonical. It's just post form. Okay, so in the beginning we have this SOP form, and then we do the double negation. We end up with the same same expression, not exactly the same, but this expression will tell you the same story, the same truth table, but in different form. One is the SOP form, the other one is a POS form. Okay, so a simple exercise is that if you were to simplify this using laws or rules, okay, you can do this very quickly. You would end up with what you have over here. Okay, it's the same thing. And if you were to draw out this truth table, they would result in the same truth table. Okay, because they are all telling the same story. They are all describing one truth table. It's just using different formats, different form. One is using post, one is using SOAP. And if you want to use canonical, you can also use canonical to describe the truth table. All right, so this will be my last example for the day. Yeah, it's been 1 hour for the class, and for today also we have I have 2 quizzes. Not 2, it's 1 quiz, but I have 2 questions in the quiz. All right. So given this, so I'm just going to briefly elaborate here right now so that you know what to do. So in the first question, you would see something like this: a Boolean function f, and it's given here. That is the expression. Now, first one is draw the gate level implementation of Boolean function f. So gate level implementation means what? Gate level implementation means draw the logic diagram. So over here you have A and B, right? Then you have an AND gate, and you have A, and then you have B bar or something like that. So that is what gate level implementation means. Okay, truth table. I believe you know how to get the truth table, and then you have the maxterm list. Okay, I also believe you will know how to get the maxterm list from today's class. Okay, so yeah, same thing over here. You have expression, truth table, expression, gate level, and then truth table, and then you have maxterm list, or you have minterm list also. Okay, the maxterm or minterm, if you get one, then you can convert to the other one. Okay, is that clear now? Do you guys have any other question?
Sure. So do we need to find the mean term?
Yeah, refer to the question later. It's specified in the question. So maxterm or minterm depending on the question. Okay.
All right, sir.
Yeah, it's not exactly the same like what I have on the slide. Read the question carefully. Everything is specified in the question. Okay, is there any other question? If no, then we will end our class today. I wish you have a good weekend, and if there is any question, any issues at all, feel free to stay back, and I will be here to answer your questions, your queries. Goodbye, stay safe, take care everybody.
Thank you, sir.
Right, you're welcome.
Hello, sir.
Yes.
I think you give us for question number 1 and 2, the question is related to this today's lecture. So maybe most of us cannot answer the question.
Which one? Which one are you talking about?
Quiz 4.1.
Oh,
Question number 1 and 2. So I cannot answer because this is that question is related to this lecture to this lecture.
oh, okay. So yeah, I see what you mean. No, don't worry. No worries about that. Maybe there is some kind of something that I overlooked in the past class.
All right, thank you, sir.
Yeah, I will reconsider that 2 questions.
Thank you, sir.
All right.